Thank you for joining us here in WBZ. It's a small chance, but the odds are going up again. An asteroid now has a 3.1% chance of striking Earth in 2032, just 7 years from now. The highest probability ever assigned in modern asteroid keeping. We don't want to alarm anyone, but we want to get the facts straight. So today we're speaking with MIT professor and astronomer Richard Binzel. Thank you for joining us, Professor.
My pleasure.
Could you start just a little bit by telling us about asteroid 2024, YR4, how it was discovered and when it was discovered?
Sure thing. We have telescopes that are now routinely searching for asteroids that come near the Earth. They've always been there over the long course of history, but we just now have the capability of seeing them as they go by. This one is smaller than a football field. Maybe about the size of a football field, about 50 meters across. And it's on a path where it comes near the Earth. We know it comes near the Earth every 4 years or so. And as we project forward from just the little tiny piece of the orbit, we're not exactly sure where this asteroid will be in the year 2032. It will be anywhere between the Earth and the Moon or beyond. But we just don't have enough of it measured to know for sure.
Well, and one of the reasons that we're talking to you today and why this asteroid in particular is in the news, we saw that the odds went up and jumped to 3.1% of a chance to hit Earth. What are the reasons behind that increase in odds?
Sure. So tracking an asteroid and predicting where it's going to be is a little bit like a hurricane track, where maybe you see a low pressure system in the Gulf and then you're trying to estimate where it's going to go. And those first estimates could be the entire Gulf Coast or even most of the Atlantic. And then as you track it a little bit, the uncertainty or that window of where the hurricane could go starts to shrink. But if you're a resident of the Panhandle, you say, oh my gosh, it's shrunk, but my Panhandle house is still in the path. And so as we get more and more measurements, we keep tracking the asteroid. That uncertainty window, that broad range of where it could go, is going to shrink and shrink and shrink. And until the Earth falls outside of that pathway, we're going to see these probabilities bounce around. They can go up. That's just kind of the normal process of how asteroid tracking and these orbit calculations work. But you know, the odds are greatly in our favor that once we get enough data, it might take us a few months, but once we get enough data, we'll be able to say for sure that this asteroid is going to safely pass by.
Is it true that this is now the most dangerous known asteroid since modern tracking began? It's something that we've read on a few different sites today, but figured we'd go right to the expert. Is that actually the truth?
Well, it's the highest probability we've seen. And again, we're talking a 3% chance, so that means their odds are 30 to 1 in our favor that it's going to miss. So we don't usually see an object go up to this high probability, but it's simply that number is simply a product of uncertainty. It's basically the product of just having limited measurements. We've only seen a very tiny piece of this in 4-year orbit of the asteroid. We've only looked at it for 2 months out of the 4 years that we'd like to track it. And so we're going to have uncertainty in the answer. So we just have to have a little patience and just keep tracking, keep on tracking. And that's what we're up to.
Well, and for our viewers at home, we just put up a graphic with the Torino hazard impact, which we know you had a major hand in being a part of. Can you explain what that scale means and why we're at a 3 right now?
Sure. So the Torino scale, puts into context an asteroid for which we don't immediately know has zero hazard of impact, zero chance of impacting the Earth. So it's a 10-point scale. We're only at 3 on the scale. We would rather not get to 8, 9, or 10. 8, 9, or 10 means that an impact would happen. 10 is what got the dinosaurs. And 8 would be the case of something like what was over Tunguska, Siberia in 1908, an object that probably wouldn't reach the ground, but the pressure wave in the atmosphere could reach the ground. And that's what this size object might mean. So a 3 just simply means that it's more than a 1% probability that it would be just a localized event if it did strike the Earth. But most of all, when you're at category 3, it says the most likely outcome when we get more data is that it will fall to 0. So it's just sort of a placeholder that reaches a level that says, astronomers, take a look at this object and let's make sure it's going to miss.
You mentioned a little bit the size of a football field. I've seen in some publications there's a range somewhere between say 40 and 70 meters or somewhere in that. Can you talk about what the difference is between the lower end of that range versus the upper end, as far as impacts would be concerned?
Yeah, the uncertainty is we just simply don't have enough measures of the object. It's very small, so it's hard to measure. In that range, it's very much in the range of what Tunguska 1908 was, in the sense that it's unlikely the object itself would reach the ground. It would probably break up. The atmosphere would shield us from it, but that doesn't shield. The atmosphere doesn't shield us from a pressure wave that happens when the thing basically breaks apart in the atmosphere on its way down. So the size, we'd like to refine it. But I think we have a good enough handle on the size that we know that this is just a localized event if it comes to pass, and not anything that would be, I'll say, globally threatening.
Well, in a few years from now, we get closer to that halfway mark. How close do you think it'll be in about 2028? What kind of things might change your assessment as it gets closer?
Yeah, so this object comes around every 4 years. It will be back around close to the Earth in 2028. We know the 2028 missed distance is further than the moon. That'll give us a chance to really refine the orbit. But, we're hoping that we can get enough tracking on it with ground-based telescopes. The asteroid is small. It's moving away from us right now. We're going to bring James Webb Space Telescope to bear to keep tracking it after our telescopes on the ground can't follow it anymore. And so we're hoping just over the next month or months, we'll get a long enough track to cast forward where this thing is going to be. And if necessary, we'll certainly be watching it when it comes back around in 2028. But we're hoping we'll have enough data to give the all clear long before 2028.
One more question for me, Professor. It seems like we hear about these near-Earth objects or asteroids every once in a while. And sometimes it can be just a few days before it's passing by. Or is there a reason why we can't sort of track and detect more of them, or maybe it's just a lack of resources, or is it just really just too difficult to see these objects whizzing by in space?
It's a bit of all of the above. We're just getting the capability to find these objects. I mean, the small things, dust. The Earth collects tons of meteor dust every day. An object the size of a basketball hits daily. Something a little bigger, that a small car enters the atmosphere, breaks apart, and gives you meteorites several times a year. So it's a little bit of a shooting gallery out there, but most of it's very small, just dust particles. This object, 2024 YO4, is just big enough that it would be some cause for concern if it were to impact the Earth's atmosphere. But it's really right on the limit of the objects we're able to detect. And, these things are out there. They've always been out there. And so really, it's just a measure of our capability as much as anything. They're there. These objects are there. We're just starting to see them. So it's simply a new era. It's just sort of the dawn of a new age and a new technology of asteroid detecting, and ultimately is going to make us safer because those objects are there. And if there's one with our name on it sometime in the next century or so, we're likely to be able to find out.
And I'm sorry, just one more question, because some folks in the newsroom are talking about this. What about our ability? I think this comes out of just all the recent movies that have been, we see Bruce Willis, drilling into an asteroid. Is there really a reasonable, are we at the point now, technology-wise, that we could actually do something to prevent an asteroid from hitting Earth were one actually headed our direction?
So NASA actually tested it. This was a mission called DART, which was an asteroid redirect test, a fancy NASA name, where we impacted an asteroid and then deliberately impacted an asteroid with a spacecraft and then measured the offset in the target's orbit. And it was quite successful. So we have demonstrated the capability to deflect an asteroid and change its orbit if we need to. And the most important thing about a deflection mission is you want to do that so many years in advance that just a tiny deflection means it misses the Earth by a wide margin when that object eventually makes that close flyby in our neighborhood.
Well, I think Professor Richard Binzel's sort of lackadaisical and calm approach to this interview is making us feel better.
Yes.
He does not appear alarmed, and so thank you again for coming on with us and giving us some great info. We'll definitely be checking back in.
Closely along,
yeah,
something
we'll
our viewers are very interested in. So we really thank you for your time and joining us today.
My pleasure. Let's reconnect anytime. I'll give you the best update I can.
Thank you, Professor.
Thank you.
That'll wrap it up for us for now. We'll definitely keep you posted on asteroid 2024 YR4 as more information comes in.
Sure, there's going to be some new updates along the way, and tonight we'll have more information on this as well at 5 o'clock on WBZ News.
Thanks for joining us.